Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help to provide an example here of how to calculate a velocity of one object relative to another. So what we're looking at here, this is example 25 on page 25 in your dynamics text. We've got this train that is moving along at, what does it say here, 60 mile per hour to the right. And then this car moving at 45 mile per hour at an angle of 45 degrees. Why don't we call that north of east? I guess I don't know for a fact that this is north in this picture, but I guess I'll restate that to 45 degrees here with the positive x-axis. Now, the way you determine the relative relationships here is we look from an observation point maybe over here. All right, so imagine we're standing here and observing this. And the first thing we'll do is we'll start with position vectors. So here is a position vector that points to the car. Since this says point A here, why don't we call this position vector A? And then here is a position vector for the train. Now what we're looking for, let's see. It says find the velocity of the train with respect to the car. Ooh, funny looking two there, but all right, so this vector from here to here is the position of the train with respect to the car, because that's a vector that points from the car to the train. Now the key to these problems is understanding the vector diagram, and the important thing to realize is these two vectors are tip to tail. So in the picture that I have drawn, the resultant vector is the position vector for the train. So the position vector for the train, we can say, is equal to the position vector for the car, I call it car A here, I guess, plus the position vector of the train with respect to the car. Now, these can be turned into velocities easy enough by time differentiating. So this becomes the velocity of the train is equal to the velocity of the car, or I guess I call it car A here, plus the velocity of the train with respect to A. And the velocity of the train is 60 miles an hour to the right. Why don't we call that 60I, and we'll put the units way over here in mile per hour, equals, now the velocity of A, the car A here is moving at an angle of 45 degrees, and it's moving at 45 miles per hour. So in vector form here, using unit vectors, the velocity of car A is going to be 45 miles an hour times the cosine of 45 degrees in the I direction, plus 45 mile per hour times the sine of 45 degrees in the j direction. All right. And now I'll just add here plus velocity of the train with respect to A. And now it's just a simple algebra problem here to solve for this. So the velocity of the train with respect to A is going to be this minus these two things. So that's going to equal 60 minus 45 cosine 45 I, whoops. Yep, that's correct. Okay, yep. So that's this minus this. Then we're just going to have minus 45 sine 45j. And I'll just put the units out here. These are in mile over hour. And that's it. So there's an expression for the velocity of that train with respect to the car. And this particular question doesn't have anything to do with accelerations, so I'm going to end it right there. I hope this video helps you understand how to calculate a relative velocity. Have a great day.